Hello everyone, myself Pawan Makwana, Assistant Professor of EC Department at LJ Institute of Engineering. Welcome to the session of Radar and Navigational Fields. In the previous session we have started with number 2, that is a radar equation. In previous session we have seen what is the relationship between pulse repetition time, pulse repetition frequency, duty cycle and its raised time with average power and the peak power, right? So in today's session we are going to study how the signal is going to be received based on what is the level of signal to noise ratio, what is a noise equivalent power, and what should be my value of threshold level to detect any target. Okay? And lastly, we will study the pulse radar. So, for the signal to be received, we must know what are different parameters that are going to be affected. So, the first one is transmitted power. That is P, right? Transmitted power is directly proportional to the radar range. If the range is going to be increased, the transmitted power is also going to be increased. Okay? Second, transmitter antenna gain. Now, the antenna gain is must because how much amount of power is going to be transmitted that directly depends on the gain of my antenna. And we know that the multiplication of transmitted power with the gain is called the effective isotopic rated power that we have already studied in the subject satellite communication. Right? It is a product of PT and the G. Right? Third, as a signal is going to be traveled through a space, we need to consider a space loss, right? Fourth, the target gain factor, because target has a different shape. So based on that, we need to consider what is the gain of my target, right? Fifth, the space loss. Why these two space losses are there? Because the first space loss is for it is going to approach any target because it is going to be transmitted. The signal is going to be transmitted from the antenna to the target. So for that we need to consider the space loss. But while the signal is going to be returned from the target to the radar, for that time we need to consider the space loss. Right? Receiver antenna, because based on the gain of the receiving antenna, how much amount of signals are going to be received of the radar. Okay, and what is the radar receiver power? It also depends on the effective aperture of my radar. Right? So these are the parameters which you need to consider while we are dealing with the reception of signal. So from this graph you are able to identify that the signal strength is going to be decreased as it reaches to a radar receiver. Why? Because it has to travel thousands of kilometers. Alright? So, as the signal has to travel through a space, some part of the signal is going to be absorbed, and for that, my signal is going to be attenuated and the loss will be. Alright? So, this is how the signal strength is going to be dependent when the signal is going to be transmitted in the space. Okay? what is signal to noise ratio? So it is ability to recognize a target in the presence of noise. Why? Because noise is always present. At some range, noise is greater than the target's frequency. That means the value of noise, amount of noise is more when we are going to receive an echo signal, because that echo signal also includes the signal which is going to be reflected from the fixed targets like mountains. Alright? Second point, the noise will also sets to the absolute lower limit of its receiver sensitivity. So the average amount of background noise is called the NEP, that is the noise equivalent power. Right? So for that, we need to understand what is a threshold level. So the threshold level is used to suppress excess noise, because a signal to noise ratio sets a threshold for detection of target. Right? What it determines? Determines whether a target is present or not. Right? Second point, if the signal to noise ratio is 1, then what does it mean? It only returns signal power equal to or greater than the background noise which is going to be displayed on the scope. Right? Now the next term is the noise equivalent power and how it is going to be affected when we are going to receive the echo signal. As I have told you that noise is always present, it can be internal or from the external source. Right? So the pulse is returning from the long range, that is from the long distance, can be a less than the ambient noise level. Right? So it will also sets a lower limit for radar's receiver sensitivity. As I told you that the average amount of background noise is called the noise equivalent power. That is always expressed into watts, because it is nothing but a power. Right? So how to determine the threshold level? You can see over here that this is the example that I have received this echo signal. You can see over here there are so many spikes. Okay, but there are 4 peak over here shown as. You can see that there is a target which is present over here, because this has a more amplitude. Right? But we can't be sure that it is our true target or the false target, whether that is present or not, because the signal that can also be reflected on the fixed target also. Alright? So this is the echo signal which is varying with the time, and we have defined the noise level over here. Right? This is the mean noise level. This is the mean noise level. We can see it here. Above this red line, we can say this can be my targets, and these 2 are the noise spikes. This is the actual value. Okay? These 2 are the noise spikes, and these 3 are the targets. If the threshold level is higher than this, how? Over here we have defined 2 thresholds. One is for TL1, that is threshold number 1, that represents if the spike has the value greater than the threshold level, then we can conclude that the target is present, otherwise not. Right? So over here it is presented for 3 targets. But we can say that these two also have the peak value. Okay? But it is not actually a target. So, from this threshold, we can see that there are total 1, 2, 3, 4, and 5. 5 targets are there. But these two are not the actual target. Okay, so for that we need to redefine the threshold value. But before that, we need to understand that how the target is going to be displayed on the score. So over here, this is the pulse position indicator, in which in center the radar antenna is there, which continuously scans in according to its maximum range, that whether the target is present or not. But it has detected there are total 3 targets over here, and over here. Okay? But these two are the false target. Right? So how to determine the false target is present over here or not? We need to redefine the threshold value like this, threshold number 2. Right? That means above this threshold value, if I am going to receive any signal which has a peak value above this, then only targets are known. Okay? And remainings are the false target. This and this. You can say that these two are my noise spikes.